Okay, so this will be a review for test 2. And so test 2 consists of chapter 6, sections 1, 2, 4, 5, 6, 7, 8. So pretty much all of chapter 6, except for 6.3, which we did not cover. So you can ignore 6.3. Right, so let's start with the question. Find the greatest common factor, right, the GCF. We have 24x to the 4 y squared, 40x cubed y to the 4, 56x to the 5 y to the 3, and 72x to the 7 y to the 5. So let's just start with the numbers first, right? We have a 24. Oops. Use a different color here. All right, so 24, 40, 56, and 72. So let's find their factors, right? Just do a factor tree. 24 is 4 times 6, right? And 4 is 2 times 2. And 6 is 2 times 3. So for 24, we have 2 to the power 3 times 3. 40, right? 40 is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. So for 40, we have 2 to the power 3 times 5. Those are the prime factors, right? 56. Again, there's a lot of ways of multiplying two numbers. So 7 times 8, right, is 56. 8 is 2 times 4, and 4 is 2 times 2. So 56 is going to be 2 to the 3 times 7. 72 is 8 times 9, right? 8 is 4 times 2, 4 is 2 times 2, and 9 is 3 times 3. So for 72, we have 2 to the 3 times 3 to the 2. Okay, so for the GCF, greatest common factor, right, we take each prime factor to the lowest power. So I see a 2 everywhere, so there's definitely a 2. And what's the lowest exponent? Well, we have a 3, a 3, a 3, and a 3. So I guess we'll have to pick the 3. That's the only exponent, right? But it's the smallest exponent. So 2 to the 3. All right, what about the other factors? So I have a 3 in the first number and a 3 squared in the last number, but there's no 3 in 40, and there's no 3 that's a factor of 56. So, yeah, it looks like there's no 3 here, right? And there's no 5 either. There's only a 5 that's a, oh, sorry about that. There's a 5 that's a factor of 40, but 5 is not a factor of any of the other numbers, right? It's not a factor of 56 or 72. And the 7 is a factor of 56 here, but it's not a factor of 72 or 40 or 24. So the only number that all 4 of these numbers have in common is the 2 to the 3, right, which is 8. Okay, now all of these also have a factor of x in it, right? So now we got to go back to these original ones here, right? So look at all the x's and look at all their exponents. Oops, the x. So we have a 4, a 3, a 5, and a 7. Out of those 4 numbers, which one's the smallest? That would be the 3, right? So x to the 3. And what about y? So for the exponents, we have a choice between a 2, a 4, a 3, and a 5. Out of those 4 numbers, the smallest is the 2, so this will be y squared. Okay? So the GCF, the greatest common factor, is just going to be 8, x to the 3, y to the 2. and we're done. Okay, so that's good first example here. Let's do another one. Okay, so similar question, factor out the greatest common factor, GCF. We have 16x to the 6 minus 24x to the 4 plus 42x to the 3 minus 8x to the 2. So before we can factor out the GCF, we have to find the GCF. So for 16, of course, 16 is 2 to the 4. 24 is going to be 2 to the 3 times 3. 42 is going to be 2, let's see, so this is 2 times 21, right? And 21 is 3 times 7, so 2 times 3 times 7. And 8, of course, is just 2 to the 3. So it looks like the only thing all of these have in common is just the 2, right? 2 to the 1. 1 is the smallest power. And as far as the x's go, the smallest exponent is 2. So the GCF is just going to be 2x squared. So let's factor that out. Right? And now we just divide. 16 divided by 2 is 8. X to the 6 divided by x to the 2 is x to the 4. Right? Yeah, so negative 24 divided by 2 is negative 12. Right? X to the 4 divided by x to the 2 is x to the 2. And 42 divided by 2 is 21. And x to the 3 divided by x to the 2 is x. Minus, right? So 8 divided by 2 is 4, and x squared divided by x squared is, well, 1. So that's it. Okay, so that's all you have to do here. Is just find the GCF, the 2x squared, and then factor it out. Right? And that's, I mean, you should look further, right? After all, this has 4 terms, and so it's possible that we can factor it by grouping. So can we factor it by grouping? Well, the first 2 terms here, I guess I should keep the 2x squared. Right? We can take out a 4x squared, I think. So let's do it this way. And when you divide, you just get 2x squared minus 3. But from the last 2 terms, they don't have anything in common, right? The GCF is 1. So it doesn't look like these match at all. They're not even close. So that tells me it's not factorable by grouping. So as it turns out, this here was the, get rid of that, was as far as we can go. So that's our answer there. Okay, so at this point, let's move on to the practice test. Okay, so number 1 is just to factor completely or write prime if it's not factorable over the integers. So let's start with A, 6x squared plus 15. Right? And this one should be relatively simple. After all, 6 and 15, right? The only thing common to the 6 and 15 is the 3, right? And there's no x that's common to both. So just factor out the 3. And when you factor out the 3, you divide 6x squared divided by 3 is 2x squared, and 15 divided by 3 is 5. And you can try to factor this, but it's not the difference of squares, right? 5 is not a perfect square. And it's a sum, not a difference. And 5 is not a perfect cube, so this is not a perfect sum of squares, sum of cubes, or certainly not a difference of cubes. And so we know we're done, right? That's as far as we can go. Okay, next up is part B, 5x to the 5 plus 20x to the 3 plus 10x squared. Right, so again, the first thing you always look for is GCF. And in this case, I think 20 is 5 times 4, 10 is 5 times 2. So everything has a 5 in it. So we'll just factor out the 5. And they all have an x as well. In fact, the lowest power of x is x squared, so we can factor out the x squared. All right, and when you divide, you just get x to the 3 plus 4x, right, plus 2. Okay. Now, what's in the parentheses, right, this is a trinomial. And so you might think it's factorable in some way or another. But notice this is x cubed, not x squared. And even if it were x squared, what two numbers multiply to 2 and add to 4? Well, there aren't any, right? 2 is just 1 times 2. But 1 plus 2 is 3, which is not 4. So that tells me that this here is prime. There's nothing further we can do here, right? And so we're done. This is the answer here. Okay, moving on to part C. We have 2x cubed minus 8x squared plus 3x minus 12. So let's start with the GCF. Notice there's no x at the end here, so we can't factor out an x. We have a 2, an 8, a 3, and a 12. So the 3 and the 2 here, right, they don't have anything in common. So the GCF here is 1. Right? So we can't take out a 2 from everything because there's no 2. That's a factor of 3. And obviously we can't factor a 3 out of the 2 or the 8. So GCF is 1, right? However, at this point we can count that there are 4 terms, right? 1, 2, 3, 4. And so we should check if we can factor by grouping. Right? Is that possible? Okay, so I made a little more room here. So remember how grouping goes, right? When you have 4 terms, it's 2 and 2. You divide them up, and you factor from the first 2 terms. The GCF of just the first 2 terms is going to be 2x squared. Right? And when you divide, you just get x minus 4. Okay. Now, factor the GCF out of just the last 2 terms. In this case, you're factoring out a 3. And when you divide, 3x divided by 3 is x. Negative 12 divided by 3 is negative 4. So here we can see that the x minus 4 is now a common factor itself. Right? So we can factor out the x minus 4. And what does that multiply? That multiplies the 2x squared plus the 3. Right? And 2x squared plus 3 is prime. You can't go any further there. And so we're done. Right? And this is how I would write it, but you can also write it in the reverse order. 2x squared plus 3 times x minus 4. Right? So I've talked about this many times. The order doesn't matter when you're multiplying. Right? Okay. Part D, 32 minus 4a minus a squared. Okay, so GCF, right? GCF looks like it's 1 again. Okay, so there's nothing we can factor out of all 3 of these. But it might look backwards to you, right? It looks like the a squared should come in front. So you can do that. You can always change the order. So I'll write this as negative a squared minus 4a plus 32. You don't have to, but this is how I prefer to write it. And now that we have the negative in front, we should factor out the negative, right? Think of it as a negative 1. And when you factor that out, you're just left with a squared plus 4a minus 32. Okay. So a squared plus 4a minus 32. This is a trinomial, right? So 3 terms. So it looks like we should be able to factor it by looking for 2 numbers, right, whose product is negative 32. And we're looking for a sum of positive 4. Okay, so let's go through the list. Negative 32 is negative 1 times 32, but that adds to 31, not 4. You could do negative 2 times 16. That adds to 14, which is not 4. We'll skip negative 3. That doesn't work. But negative 4 times 8 is also negative 32. And negative 4 plus 8 is 4. There's our match. Right. And so this is just going to be a minus 4 times a plus 8. And that's it. You can also write it as negative 1 times a plus 8 times a minus 4. Either way. And there's other ways you can write this. You could also write this as 4 minus a times 8 plus a. So if you got the answer not by factoring out the negative 1 like I did, then you probably did it this way. And like I say, that's okay too. So any one of these 3 would be considered correct. Right. Okay, next up, part E. Part E is x squared minus 16x plus 39. So GCF is 1, again. But it's a trinomial, and a is 1. So we're going to look for 2 numbers, right, whose product, well, we'll do it a different color. Right, the product is 39. And the sum has to be negative 16. So 39 is obviously 1 times 39, but that adds to 40. And it's not negative. So that tells me that both numbers should be negative. So negative 1 times negative 39 is positive 39, and negative 1 plus negative 39 is negative 40. But we're looking for negative 16. Okay, so 39 is not an even number, so we can't divide by negative 2. Let's try negative 3. And sure enough, 39 divided by negative 3 is negative 13. Negative 3 plus negative 13 is negative 16. And there we go. So this will just be x minus 3 times x minus 13. Right. Or if you prefer, x minus 13 times x minus 3. Since order doesn't matter. Okay, let's move on to part F, which is y squared minus 10y minus 12. Okay, so again, a is 1 again, and so the GCF is clearly 1, as it often is. And since a is 1, it looks like we can factor this by, again, looking for 2 numbers whose product is negative 12 and whose sum is negative 10. So what 2 numbers multiply to negative 12? So there's negative 1 times 12, but negative 1 plus 12 is 11. It's not 10. It's not negative 10. So that tells me we should switch and make it positive 1 times negative 12. And 1 minus 12 is negative 11, which is still wrong, but at least it's negative, right? Because we are looking for a negative 10. So let's go on. We have 2 times negative 6. 2 minus 6 is negative 4. That's no match. And I think there's only one more. Positive 3 times negative 4, right? We want the bigger number to be negative. And 3 minus 4 is negative 1. Okay, so at this point, the next number we would divide by is 4, and that gives you negative 3. And 4 minus 3 is now positive 1. So we know we're not looking for a positive number. We're looking for a negative 10. And the only negative numbers, right, when you add, you get are negative 11, negative 4, negative 1. There is no negative 10, no matter what we do, right? So I think these are the only three possibilities here. None of them match to the negative 10. Right? So that tells me we can't do this, right? There's no way to factor this, right? The answer is that this is prime. Okay? Now, how do we know it's prime? Because I checked every possibility here, and none of them match, right? None of them match to the negative 10. That's how you know it's prime. So you have to show this. You have to show this, right? You have to show every possible choice here, all the possible numbers that multiply to negative 12. When you add them up, you're looking for negative 10. If you don't find it, that means it's prime. Okay, but you have to exhaust every possibility here, right? If you give up too early, it's possible that it's not prime and you just didn't find it, right? So you have to exhaust all the possible choices here. And here there's only the 3, right? I mean, there's these other 2. There's this one and this one, but right there you don't even get to a negative sum. You get to a positive sum. So if you want to include those, right, I checked 5 possible choices here. And there's actually, I think there's 2 more. Or there's only 1 more. So you don't have to write them all down, but, you know, because this will be a positive as well. It'll be 6 times negative 2, which adds to positive 4. Again, that's not negative 10. So, all right, so just so we're clear that you got to show at least all these possible choices here for numbers that multiply to negative 12. Next up is part G, 4x squared minus x minus 5. Okay, so GCF is again 1. And this is a trinomial, but this one's a little different, right? This one's a little different because A is not 1 anymore. A is 4, B is negative 1, and C is negative 5, right? So this is not a perfect square trinomial, even though 4 is a perfect square, right? The negative 5 is not a perfect square. So this means we have to use the AC method. Okay. So the first part is to multiply A times C. 4 times negative 5 is negative 20. Step 2. What 2 numbers multiply to negative 20 and have a sum of negative 1? Okay. I hope the answer is obvious, right? It's this one right here. It's 4 times negative 5, because 4 minus 5 is negative 1. So, you know, I found it right away because I just saw it up here. Of course, there's other possibilities, right? There's 2 times negative 10, which is negative 8. There's 1 times negative 20, which of course is negative 19. But I think that's it. I mean, the others give you positive numbers. So in this case, we didn't have to bother with these. We found it right away. You know, so if you're lucky, you might find it right away. If not, you go through the entire list. In this case, there's only 3 of them. So it won't take you too long. Okay, so at this point, we're going to split up the negative 1x here and write it as positive 4x minus 5x. Right? Again, that comes from the 4 and negative 5 earlier. Right? Yeah, 4 minus 5, right, is negative 1, so 4x minus 5x is negative 1 times x. Right? So that's the split. All right, now we have 4 terms, so now we can factor by grouping. So again, just split it up. From the first 2 terms, you can factor out a 4 and an x, so 4x. And when you divide, you get x plus 1. From the last 2 terms, you can factor out a negative 5, and you're left with x plus 1. Right? So now we just factor out the x plus 1, and that factors as 4x minus 5. Right? So there's our answer, x plus 1 times 4x minus 5, or the other way around, 4x minus 5 times x plus 1. Either way. Okay, so that's an AC method. Right, and next one, H, is 10n squared minus 29n plus 10. And again, you can check that the GCF is 1, because 29 is a prime number, so it's not divisible by 10, or 2 or 5, or any factors of 10, right? So 10 is just 2 times 5. But 29 is not divisible by either 2 or 5. So that's how we know the GCF is 1. Okay. So this looks like another AC method. A is 10, B is negative 29, and C is 10. So part 1, A times C is 10 times 10, which is 100. So we're looking for a product that's equal to 100. Oops, sorry, 100. And the sum is B. The sum should be negative 29. So what 2 numbers multiply to 100? Well, there's 1 times 100, but that adds to 101, which is not negative, right? We're looking for a negative 29. So both numbers should be negative. Negative 1 minus 100, is negative 101. Still wrong, but at least it's negative, right? So if you divide by negative 2, you get negative 50. Negative 2 minus 50 is negative 52, not negative 29, so we move on. Can we divide by negative 3? Not evenly. Can we divide by negative 4? Sure, right? Negative 4 times negative 25 is positive 100. And negative 4 minus 25 is negative 29. That's what we're looking for. That's our match, right? So the 2 numbers, we're going to split up the middle term, the negative 29n, as negative 4n minus 25n. Okay, so let's do that here. So we'll keep the 10n squared, that's the first term, minus 4n minus 25n, and then plus 10. Okay. Yeah, so this is step 3. We're just going to factor by grouping now in step 4. So you split this up. The first 2 terms, you can factor out a 2n as the GCF, right? And you're left with 5n minus 2. From the last 2 terms, it looks like we can factor out a 5. But since the first term is negative, we'll factor out a negative 5. And when you divide, you get positive 5n minus 2. So we got the 5n minus 2 is our common factor now. Right? So we'll factor out the 5n minus 2. And what does that multiply? Right? It multiplies 2n minus 5. Right? So 2n minus 5 is the other factor. And again, we're done, right? So again, this looks backwards, right? But it's either way, 2n minus 5 times 5n minus 2, or 5n minus 2 times 2n minus 5. All right, let's move on. All right, part I, x squared plus 8xy minus 33y squared. So again, the GCF is 1. And it's still a trinomial. And in some ways, this might be easier, right? Because A is 1, B is 8, and C is negative 33. Right? So we could use the AC method, although in this case, because A is 1, you can also use the shortcut. Right? It's the same shortcut we did in, say, part E and part F earlier. But I'm still going to use the AC method because why not? We've been using it all along here. So the first step is to multiply A times C, which is just negative 33, right? 1 times negative 33. So we're looking for two numbers, right, whose product is negative 33 and whose sum is positive 8. Okay, so negative 33, we want the bigger number to be positive, right? So negative 1 and 33, negative 1 plus 33 is 32. So that's no match. And we know we can't divide by 2 here, but we can definitely divide by negative 3. That gives you 11. And negative 3 plus 11 is 8. So we got it. We're done. Well, we're done with finding the numbers, right? So this 8xy, that's the middle term, will be split up as negative 3xy plus 11xy, right? Because negative 3 plus 11 is 8, right? Negative 3xy plus 11xy is 8xy. So this middle term, break that apart. We'll still keep the x squared, right? Minus 3xy plus 11xy minus 33y squared. Right, so that was step 3. And step 4, at this point, should be obvious because there's 4 terms. We use grouping. So now factor from the first 2 terms, all we can factor out there is an x. And x squared divided by x is x. Negative 3xy divided by x is negative 3y. From the last 2 terms, what's the GCF there? Well, it's going to be 11 and y, right? They both have a y in it. So when you divide, you just get x minus 3y. And this is looking good because these match. The x minus 3y is our common factor. So when we factor out the x minus 3y, we multiply by the x plus 11y. And I think we're done. There's nothing else to do. Again, some of you might have switched these around, and if you switch them around, you probably got x plus 11y times x minus 3y. Perfectly acceptable. I just switched the order, right? All right, so that's part I. Let's move on to part J. So we get 16c squared minus 8c plus 1. And so that 1 tells me that the GCF is yet again equal to 1. All right. And so A is 16, B is negative 8, and C is 1. Not this C. Be careful. The C is the variable here. If that bothers you, then I guess you can change it to an X if you like. But I'll leave it as C as long as you're aware that this C is not the same C here, right? Okay, so we can use the AC method again. Right, so A times C, step 1, is 16 times 1, which is 16. So what two numbers have a product of 16 and a sum of negative 8? Okay, so we know they're both negative. It's not negative 1 and negative 16. It's not negative 2 and negative 8. It's got to be negative 4 times negative 4, right? Negative 4 plus 4, negative 4 plus negative 4 is indeed negative 8. So negative 4c minus 4c is negative 8c, and that's what we're going to split up here. Right? 16 times 1 is 16, 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 16 So split up the negative 8c as negative 4c minus another 4c plus 1. Factor by grouping. So the first two terms we can factor out a 4 and a c. And we're left with 4c minus 1. Oops, it looks a little funny. Yep, 4c minus 1, right? And then from the last two terms, we really can't factor out anything except the negative sign. So negative 1 times 4c minus 1. So the 4c minus 1 is our common factor. And what does it multiply? Well, it multiplies 4c minus 1, which I know is a little confusing, but it's the same thing, right? So as it turns out, this is a perfect square. It's 4c minus 1 squared. And in fact, this would have been a lot faster had you noticed that, hey, the 16 and the 1 are perfect squares, right? So we could have factored it much faster if you just noticed that this was a perfect square trinomial. Oops, it's got to be a plus 1, right? Yep, so this is 4 times c squared minus 2 times 4c times 1 plus 1, right? So a squared, let me scroll down a little bit here, right? This is nothing more than a squared minus 2ab plus b squared, which factors as a minus b squared, where in this case a is 4 times c and b is just 1. So if you notice that pattern here, this is just 4c minus 1 squared. Right. So that would have gotten the answer a little bit faster, but the AC method works just as well. It just takes a little longer. Okay, moving on to K. Okay, y to the fourth plus 4y cubed minus 21y squared. GCF is not 1, it's 1y squared, right? Y squared is the smallest power of y is 2. So that means we can factor out the y squared, leaving us with y squared plus 4y minus 21. Okay, can we stop there? Well, let's be careful about this. The y squared y squared plus 4y minus 21 is now a trinomial. At this stage, right, a is 1, b is 4, and c is negative 21. So let's look for two numbers whose product is negative 21 and whose sum is, that should be a 4, positive 4. Okay, so negative 21 is not negative 1 times 21, or it is negative 1 times 21, but negative 1 plus 21 is 20, which is not equal to 4, so that doesn't work. Sorry, it's not negative 20, negative 21. It's also negative 3 times 7, and negative 3 plus 7 is 4, and there's our match, right? So all we have to do now is, after we factor out the y squared, right, this is y minus 3 times y plus 7, right, or vice versa. Right. So just letting you know, it's also y squared times y plus 7 times y minus 3. Either way. Okay, so, right, so I think this was our first two-step problem here. We had to factor out the GCF first, right? That's the y squared. So you got to do that first. And then you have to look to see if you can factor this trinomial, right? We did that, and it turns out it is factorable as y minus 3 times y plus 7, right? So, right, be careful, because if you leave it like this, even though it's factored, it's not factored completely. So you'll get partial credit for this, but you won't get full credit. You'll lose points for not factoring all the way, factoring completely. Got it? All right, moving on. Part L, 9x squared minus 30xy plus 25y squared. How do we factor that? So GCF, we're back to 1 again, because there's no x in the last term, there's no y in the first term, and 9 is just 3 times 3, so it's actually 3 squared. Right? And 25 is 5 squared. So the 3 and the 5 have nothing in common, right? However, notice that the first term is a perfect square, and the last term is a perfect square. So this might go fairly quickly, because this should factor as, again, this is a squared minus 2ab plus b squared, where a in this case is the 3x, and the b is 5y. So this should factor as a minus b squared, or in this case, 3x minus 5y squared. Right. Oh, we're not done yet. Actually, we don't know that for sure. What did we forget to do here? We forgot to check the middle term. Is the middle term negative 2ab? So we have to be careful about that. So negative 2 times a, remember a was 3x and b was 5y. So let's multiply that out. Negative 2 times 3 is negative 6. Negative 6 times 5 is negative 30 times x times y. Yep, that's a match. So, right, so now we know for sure that this is correct. In other words, I can erase the question mark here. Yep. Trying to erase that. Right, and now we can highlight this. Oops. As our answer. Okay, so we did this, right, as a perfect square trinomial, right, one of these. If you use the AC method, that would work as well, right? But this is one that you should be able to recognize. The 9 and the 25 are perfect squares, and so it's a good candidate for a perfect square trinomial. Again, you have to make sure you check the middle term, or the other way to check, of course, is to multiply this out and just use FOIL here. So when you multiply this out, you do get 9x squared minus 15xy minus 15xy plus 25y squared. And sure enough, the middle two terms here add up to negative 30xy. Which is what we started with, right? That's the original problem. So, right, so that tells me that this is definitely correct. All right. Okay, letter M is 16x squared minus 81. I think this is the first binomial we had. There's only 2 terms here. And out of the 16 and 81, the GCF is again 1. Oh, I'm sorry. Part A, the very first one we did, letter A, was a binomial, but it was just a GCF problem here. So, okay, so this is our first non-trivial binomial. And at this stage, you know it's a difference, and it is a difference of perfect squares, right? 9 times 9 is 81. So this is 4x quantity squared minus 3 quantity squared. It's the difference of 2 squares, right? It's a squared minus b squared. A is 4x, b is 3, and a squared minus b squared factors as a minus b times a plus b, which means 4x quantity squared minus 3 squared factors as 4x minus 3 times 4x plus 3. And that's all there is to it. Okay, so that's part M. Part N, letter N, 4y squared plus 25. Okay, the 4 and the 25 have nothing in common, so the GCF is again 1. And 4 is a perfect square, right? It's 2 squared, and 25, as we saw earlier, is 5 times 5, 5 squared. So this is a sum of 2 perfect squares, right? In other words, the A is 2y, and the B is 5. Okay, so how do we factor a squared plus b squared? We don't. It's prime. So yeah, there's no way to factor this because it is not the difference of 2 perfect squares, right? It is the sum. And when you add 2 perfect squares, a squared plus b squared, we are considering that prime. I think I mentioned there are some cases where it's not going to be prime, but we're going to consider it prime. Those are much more advanced than need to be, right? So yeah, the sum of squares will always be prime, right? So the answer here is prime, right? And I think it's I think we only saw one prime before this. So there aren't that many that are going to be prime, but a few of them might be, and this is certainly one of them that is prime, right? So if it was 4y squared minus 25, yeah, that would be 2y quantity squared minus 5 squared. That would factor as 2y minus 5 times 2y plus 5. But that's not the problem, right? The problem had a plus sign. This has a minus sign. There's a big difference between adding and subtracting. Even though that's the only difference between these two, it's a big difference. Because with the plus, it's prime. With the minus, it would be factorable. Got it? Okay, so that's part N. Okay, letter O is 64x cubed minus 125. Okay, so the 64 and 125 have nothing in common, so the GCF is, yet again, equal to 1. And 64 may be a perfect square, but that doesn't matter here because the 2 and the 3 as exponents don't match. So we don't want to think of 64 as 8 times 8. We want to think of it as 4 times 4 times 4. In other words, 4 to the power 3. Likewise, the 125 is also 5 times 5 times 5, or 5 to the power 3. Right? So this is 4x, the quantity cubed, minus 5, again, the quantity cubed. Okay, so this one's a little trickier because it's a cubed minus b cubed. Okay, and right, by now you should know this, right? It factors as a minus b times a squared plus ab plus b squared. Okay? Yeah, you got to know that. This is the only way you're going to be able to do this. I mean, the other way is by doing division, but most people find that more confusing. So I would make sure you know this, right? In this case, the a, the capital A here, is just 4x, and the capital B is 5. So a minus b is 4x minus 5. Right, now what's a squared? So a squared is 4x squared, right? It's 4x times 4x, which is 16x squared. I'm assuming that most of you can do this in your head. You don't have to write it out if you don't want to. I'm just making it abundantly clear. What's a times b? Well, a is 4x and b is 5. So 4x times 5 is 20x. Again, you don't have to write that out, but it might help. And what's b squared? B squared is 5 squared. 5 times 5 is 25. Okay? So that's bad enough as it is. Now we have this trinomial. Remember, a trinomial, you might want to use the AC method here. However, as I think I've mentioned many times already, this trinomial here, when it comes from the difference or the sum of cubes, this will be prime, which means don't bother trying to factor this. You can try, but you're wasting time. It's not going to be factorable. It's going to be prime. Right? And that just means you're done. You don't have to go any further here. Okay? But the point is, right, you do have to know how to factor the difference or the sum of perfect cubes. And that's how to do it. Right. Moving on to letter P, 12x squared minus 38x minus 14. So we're back to a trinomial, right? We have 3 terms instead of 2. And the GCF here, well, notice they're all even numbers, so they're all divisible by 2. Can we divide them by anything higher than 2? It doesn't look like it, right? So 2 is the only factor between them. The 6, 19, and 7 have nothing else in common. So the GCF is 2, right? We'll factor out the 2, leaving us with 6x squared minus 19x minus 7. Okay? So that's the first step, right? Now we have to see, can we factor this any further? Remember, this is not a difference or sum of cubes, so there's no reason to think that this is prime, although it might be. We just don't know that yet, right? So at this stage, A is 6, B, let me write it up here. A is 6, B is negative 19, and C is negative 7. So using the AC method, A times C, 6 times negative 7 is negative 42. So that is our product, and we're looking for the sum of 2 numbers to be negative 19. So negative 42 is, let's do positive 1 times negative 42, and 1 minus 42 is negative 41, which is not negative 19, so no match. If we divide by 2, we get 2 times negative 21 is negative 42, and 2 minus 21 is negative 19. So already we have our match, right? So the negative 19x will get split up as 2x minus 21x. Okay. So 6x squared plus 2x minus 21x minus 7. Right. And now we just factor by grouping. Right. From the first 2 terms, we can factor out 2x, leaving us with 3x plus 1. And from the last 2 terms, we can factor out a negative 7, leaving us with, again, 3x plus 1. So we can factor out the 3x plus 1. And what does that multiply? It multiplies the 2x times the negative 7. Or rather, 2x minus 7, I should say. And now we're done. So again, 2-step process here. Factor out the GCF of 2, and then factor this by the AC method. Okay. Now, you didn't have to factor out the 2 here as the GCF. I mean, I did, because that's the best way to go. Right? You could have used the AC method, where A is 12, B is negative 38, and C is negative 14. The problem with that is that A times C, 12 times negative 14, is a rather large number. It's negative 168. So what 2 numbers multiply to negative 168 and add to negative 38? Okay, so that's the product here, is negative 168. Right, so if you did that, great. Your list is going to be a little bit longer than mine. I got it in just 2 tries. You might have to probably do 3 or 4 or 5 tries. So in this case, we didn't have to factor out the GCF first, although I think it makes it a lot easier. Because in other problems, if you don't factor out the GCF first, you're going to get stuck right away. Right? So in that case, there's nothing else to do. In this case, without factoring out the GCF, we could have done it this way. It just would have taken a little bit longer. Letter Q is n cubed plus 27. And 27 is a perfect cube. Oh, GCF is 1. Let's make sure of that. So this is n to the third power plus 3 to the third power. Okay, so this is yet again a cubed. Oh, this time it's plus b cubed. And that factors as a plus b times a squared minus ab plus b squared. Right, remember SOAP, same opposite, always positive. All right, so that's how I remember where the negative goes there. Yeah, in this case, a is just n, and b is 3. So this factors pretty simply as n plus 3 times n squared minus n times 3 is the same as 3 times n, plus b squared is 3 squared, but 3 times 3 is 9. Okay, and that's it, right? Remember, this trinomial here will not be able to go any further, so it's prime. So this is it, and that's as far as we can go. Okay, so another sum of, right, the sum and difference of cubes. Again, you got to know this to be able to factor it, because yeah, without it, you're going to get lost. There's a lot of people get this, make this harder than it has to be because you forget the formula for sum of cubes. All right. I mean, again, if you forget it, the other way to do this is to divide n cubed plus 27 divided by n plus 3. But that's a long division problem, right? You're doing all of this. Right? And that'll take a while, but you're welcome to do it that way. Right? Because what you end up with is n squared minus 3n plus 9. And so when you multiply the n plus 3 times this, right, you get the n cubed plus 27. So if you didn't follow that, don't worry about it. I'd prefer you not do it that way. On the other hand, if you forget this, or you can't look it up or anything, then sure, feel free to do it by long division. Okay, letter R is a to the 6 plus 12a cubed plus 36. So GCF is 1, right? And again, usually this is, a squared, and this is just an a. So these are bigger powers than you're used to, but it's still done the same way, right? This is a trinomial, right? A is 1, b is 12, c is 36. So you could use the AC method, or even just the shortcut because a is 1. Or you could notice that 36 is a perfect square, right? 36 is 6 times 6. And so maybe this is a perfect square trinomial, right? In other words, is this a squared plus 2ab plus b squared? So if b squared is 36, then b is 6. So what would capital A be? Capital A would not be little a, because then this would be a squared, not a to the 6. But what's 6 divided by 2? 6 divided by 2 is 3. So a cubed to the power 2, right? A cubed squared is just a to the 6. Right? So that tells me my capital A is really just little a to the 3. My capital B, as we said earlier, is just 6. So now the big question is, what is 2ab? Right? So 2ab is 2 times a cubed times 6, which is just 12a cubed. But that's a match. That's the middle term. So this works, right? this will factor as just a plus b quantity squared, or in this case, little a cubed plus 6, the quantity squared. So that's probably the fastest way to do it. Again, if you use the AC method, you might end up with a cubed plus 6 times a cubed plus 6, which is fine. It's just a repeat, right? You're just repeating the same factor. When you repeat the same factor, you really should square the whole thing. Right? Okay? And, you might, I get the question all the time, what happens if I leave it like this? Well, that's like leaving an answer like, y times y. I'd much rather have you write it as y squared. So, yeah, you might lose a point for that, and you'll probably lose a point for leaving it like that. It's not a big deal, but, you want to simplify as much as possible. Right? Okay, good. Okay, letter S. So we're almost done. We're getting to the last few here. But then these are going to be probably some of the more difficult ones. So let's start with the GCF. It's not 1 here, right? Because 24 is divisible by 3. So we can certainly factor out a 3. They both contain an x, so we can also factor out an x. And they also both contain a y, so we can factor out a y. So the GCF, greatest common factor, is 3xy. Okay, so as a first step, let's factor that out. So 3x to the 4th y divided by 3xy, is just x cubed. I'll move that down a little bit. Sorry about that. All right. Now the next term, right, it's going to be a plus. 24 divided by 3 is 8. X divided by x is 1. Y divided by y is 1. So it's just 8. Okay, so 3xy times x cubed plus 8. So that's what we have so far. However, at this stage, you should recognize that 8 is a perfect cube, right? It's 2 to the power 3. So we're going to use the same a cubed plus b cubed, right? That's just a plus b times a squared minus ab plus b squared. In this case, a is x, b is 2. So we're going to factor this as a plus b, so x plus 2 times a squared is x squared, minus ab is minus x2, or better yet, 2x, right? Plus b squared is 2 squared, which is 4. Okay. Now, don't forget the GCF. That's still there. So 3xy goes in front. And now I think we're done. Right? Remember, you can try to factor this trinomial by asking what two numbers multiply to 4 and add to negative 2. Well, you can try negative 1 and negative 4. That adds to negative 5. Or you can do negative 2 times negative 2, but that adds to negative 4. Yep, you're not going to get negative 2 here. So, yeah. So, right, as always, this will be prime. This trinomial, I should say, will be prime. Okay, so that's how we know we're done. You don't have to try to factor that any further. Although I did in this case. I tried to do it, but it was doomed to failure. We weren't going to be able to do it. Right? All right, so your final answer here, 3xy times x plus 2 times x squared plus 2, x squared minus 2x plus 4. Okay, and again, remember what happens if you leave it like this? You'll get partial credit because it is factored, right? You did factor out the GCF correctly, right? So that's correct so far, but you did not factor the x cubed plus 8. And because it's not prime, it is factorable, you're going to lose points for that. So if you want full credit, you got to factor completely, all the way. All right, moving on to letter t. We have w to the fourth minus 4w squared minus 45. All right, trinomial, right? GCF is 1. So we can move on. So yeah, what two numbers, right, have a product of negative 45 and a sum of negative 4, right? If there are any. If there aren't any, then we're done. It would be prime. But I think there is a combination here. So let's try 1 times negative 45. So that adds to negative 44, which is not negative 4. We know we can't divide by 2. Can we divide by 3? Yep. 3 minus 15 is negative 12. Still no match. We can divide by 4. Nope. But we can divide by 5 and get negative 9. And sure enough, 5 minus 9 is negative 4. There's our match. So this is going to factor as w squared minus, plus 5 minus 9. Although it doesn't matter the order, right? Oh, why w squared? Because w squared times w squared, right, is w to the fourth. Right? Yeah, it's not w plus 5 times w minus 9 because, right, you can check. This would give you w squared minus 4w minus 45. So correct numbers, but the exponents are wrong here. Right? This should be a 4 and this should be a 2. So that's why it's w squared and not just w. All right, w squared plus 5 is prime. So we're done with this. We don't have to go any further with the w squared plus 5. However, w squared minus 9 is w squared minus 3 squared. And that looks an awful lot like a squared minus b squared. Right, where a is just w and b is 3. And now this is the easy version, right? A minus b times a plus b. Right? It's not cubes anymore, it's just squares. So we can factor the second factor here, right? We'll leave the w squared plus 5 alone. But then w squared minus 3 squared is w minus 3 times w plus 3. And now we're done. So again, don't leave it like this because you'll only get partial credit. It's not factored completely. Right? The w squared minus 9 is the difference of squares. It's an a squared minus b squared problem, as I just showed you here, right? Okay. Okay, last one. Letter U is x to the 4 plus 3x cubed minus x minus 3. And we haven't seen one of these in a while where there's 4 terms, right? And 4 terms usually means grouping. But hang on, don't skip the step here. GCF, yep, is 1. Right? All 4 of these have nothing in common other than the 1. All right, so now we can do grouping, right? Now we can split this up. Do the x to the 4th plus 3x squared first, and then the minus x minus 3. So out of the first 2 terms, we can factor out an x cubed, right? Leaving us with x plus 3. And then from the last 2 terms, all we can factor out is the negative 1, leaving us with x plus 3. Okay, so the x plus 3 is now our common factor. We can factor that out. And we're multiplying by x cubed minus 1. Okay? Are we done? So the x plus 3, I think we're done with that. There's nothing we can do with that. That is prime. But x cubed minus 1. Remember, 1 times 1 times 1 is also 1. So 1 is a perfect cube. Yep, this is a cubed minus b cubed, where a is just x and b is 1. So we're going to have to factor this as a minus b times a squared plus ab plus b squared. And just replace a with x and b with 1. And that should not be too hard here. So a minus b is just x minus 1. And then a squared is x squared plus a times b is x times 1 plus b squared. Well, 1 squared is 1 times 1, which is still 1. And even though this is a trinomial, remember this trinomial here will be prime. So we don't have to factor that any further. And certainly the x minus 1 is prime, x plus 3 is prime, x squared plus x plus 1 is prime. So we're done. Yep, so this was a tricky one, right? Again, if you leave it like this, you will lose points for not factoring the second factor there, the difference of cubes. But at the same token, this is probably about as hard as it gets, right? Right. The last few of these, you had to factor twice, and in some cases you might even have to factor 3 times using different various methods here. All right. So by now we have a lot of practice in factoring, so I'm hoping that you're all experts at factoring by now. Okay, so we can move on to solving equations, right? And this all comes from section 6.7, right? The factoring comes from all the sections before that, right? 6.1, 6.2, 6.4, 6.5, and 6.6. But for 6.7, we're solving equations, right? So letter A, part A, 2u plus 5 times u minus 12 equals 0. I'm intending this to be an easy one because it's already factored, right? If it's already factored, all you have to do are set each factor equal to 0. And now just solve each equation separately, right? Let's do the first one. Subtract 5 from both sides. You get 2u is equal to negative 5. And now just divide by 2. So u is negative 5 over 2. Okay, so that's one answer. What's the other one? Well, if I add 12 to both sides, I get u is equal to positive 12. And that's the other answer, right? So again, a typical equation in this section will have 2 solutions, right? We've seen one where there's only 1, and even occasionally there might be 3, but usually just 1 or 2, and usually 2, I should say. Okay, so the only tricky thing about this is that a lot of students tend to get confused because they think they have to multiply this out. And if you multiply it out, you're going to end up with 2u squared. Let's see, minus 24 plus 5 is minus 19u minus 60 equals 0. So sure, how would you solve this equation? Well, you would have to factor the left side. And how do you factor it? Well, AC method. But I already did that for you. I factored it for you, right? So yeah, don't multiply it out because you're making it harder. Right? I mean, it shouldn't be that hard to factor this, but it's already factored. Okay. Now, in part B, of course, it's not factored. So part B, we want to solve x squared minus 4x minus 21 equals 0. Okay, so you should recognize this is a quadratic equation in standard form. Right? So A is just 1, B is negative 4, and C is negative 21. Okay, so the only way we know how to solve equations like this, right, is to factor the left side. So yeah, we're not done with factoring, right? We still have to factor. But we've done this so many times. Negative 21 is just going to be negative 7 times 3. And negative 7 plus 3 is negative 4. So it works. Now put back the equal 0 and set them both equal to 0, right? So you get x equals 7 or x equals -3. And that's it. Right? Of course, it's a good idea to check if you plug them back in. So wherever you see an x, change it to a 7. And let's calculate this and see if we get 0. Right? We get 49 minus 28 minus 21. Is that equal to 0? Well, 49 minus 28 is 21, and 21 minus 21 is 0. So absolutely, right? So 7 works. But that doesn't guarantee that the -3 will work, right? You really should check both. So I'll leave it to you to plug in the -3 again back into the original equation here. Okay. But spoiler alert, it does work, right? As you can check for yourself. Okay, part C, we want to solve x times x plus 9 equals -14. Okay, so this one's a little bit tricky because, well, first of all, it's not in standard form. It doesn't equal 0 here. So why don't we add the 14 to both sides? Right? So yeah, just add 14 to the right, add 14 to the left. And now it equals 0. However, there's no x squared, right? So we're actually going to have to multiply this out, distribute the x, right? So x times x is x squared, plus x times 9 is 9 times x, plus 14 equals 0. Okay, so now it's in standard form, right? A is 1, B is 9, and C is 14. So what two numbers, right, we have to factor this. What two numbers multiply to 14 and add to 9? So you know by now it's not 1 and 14 because that adds to 15. So it's got to be 2 and 7. 2 times 7 is 14, and 2 plus 7 is 9. Okay. So x plus 2 equals 0 gives you x equals -2. X plus 7 equals 0 gives you x equals -7. So again, two answers, -2 and -7. Okay, part D, we want to solve 3y squared minus 10y minus 8 equals 0. And this is in standard form, right? A is 3, B is -10, C is -8. And again, the variable is y instead of x. Don't let that bother you. But it looks like to factor this, we're going to have to use the AC method here. Right? So a times c is 3 times -8, which is -24. So what two numbers have a product of -24 and a sum of -10, right? Because that's b. B is -10, right? All right, well, let's start with the obvious 1 times -24. That adds to -23, which is not -10. So go on to 2 times -12. 2 minus 12 is -10. And there's our match, right? So we're going to split the middle term, the -10y, into 2y minus 12y. Right? And so now we can factor by grouping. For the first two terms, the GCF is y, leaving you with 3y plus 2. For the last two terms, we can factor out a -4, and that leaves you with 3y plus 2. So we're going to factor out the 3y plus 2 and multiply by y minus 4. And now we're done factoring, although be careful, that wasn't the question. The question wasn't to factor. That's just part of the process here. Now we have to go back and solve the equation. Remember, this was an equation, equals 0. Okay. But this is the easy part, because all you're doing is setting the 3y plus 2 equal to 0 and the y minus 4 equal to 0. So obviously y will be equal to 4. That's one answer. And then here, you take away the 2, you get 3y is equal to -2, divide by 3, you're going to get y is equal to negative 2/3. So again, two answers, right? Negative 2/3 and positive 4. Right? Yep. Again, the only way we know how to solve this is by factoring. There are other ways. I mentioned this in not the previous video, but a couple of videos ago, that there are other ways of doing it. And if you know those ways, if you know, for example, the quadratic formula, yeah, you could do it that way, but here we're doing it by factoring. Okay, so make sure you know the factoring method first, right? Right, the quadratic formula will come a lot later in the course. Okay, letter E, part E, solve 4a squared equals 19a plus 5. First thing to notice is that the right side is not 0, so it's not in standard form. So we'll just take away the 19a from both sides and the 5 from both sides. Oops, there's an a here. So 4a squared minus 19a minus 5 equals 0. Now it's in standard form. We know a is 4, b is negative 19, and c is negative 5. So to factor that, I don't think we have a choice here. It's going to be the AC method. So 4 times negative 5 is negative 20. So that's the product. And we want the sum to be, yep, negative 19. Right? Be careful you don't use the positive 19 in the original equation. That was on the wrong side. Okay, so what two numbers have a product of negative 20 and a sum of negative 19? So let's try negative 1 times 20. Negative 1 plus 20 is 19, which is not quite right. We're looking for negative 19, right? So that's wrong. But all that means is I made the smaller number negative. I should make the bigger number negative. Do 1 times negative 20. So 1 plus negative 20 is now negative 19, and that's our match, right? So the negative 19a will get split up as 1a minus 20a. So split that up as 1a minus 20a. And now factor by grouping. So take out the a, left with 4a plus 1. For the last two terms here, we can factor out, looks like the GCF is negative 5. Right? Again, keep the negative, right? And you're left with 4a plus 1. So you factor out the 4a plus 1, and you're left with a minus 5. Okay, so that's the factoring part. Again, don't stop there. Now we just have to set them equal to 0. Set the factors, I should say, equal to 0. So 4a plus 1 equals 0 gives you a is negative 1/4. And a minus 5 equals 0 gives you a equals positive 5. And those are the solutions. Okay. All right, part F. 8x squared minus 68x plus 32 equals 0. And sure enough, this is in standard form, right? A is 8, B is negative 68, and C is 32. So, right, and it equals 0. So how do we factor 8x squared minus 68x plus 32? Well, I hope you're not using the AC method. If you multiply 8 times 32, what are we going to get here? 256? That's a pretty big number, right? So what two numbers multiply to 256 and add to negative 68? So personally, I don't feel like doing that, right? Because what did we forget here? We forgot GCF. The GCF is not 1. It's not even 2. It's 4. So the first thing we should do here is factor out the 4, leaving you with 2x squared minus 17x plus 8. And that's what equals 0, right? So the 4 doesn't matter. We can divide both sides by 4. And that leaves you with 2x squared minus 17x plus 8 equals 0. Right, because 0 divided by 4 is still 0. So really, at this point, a is 2, b is negative 17, and c is positive 8. Now we do the AC method, but here a times c is 2 times 8. It's 16. So that's the product. What two numbers multiply to 16 and add to negative 17? Okay, so here you don't have to look far. It's negative 1 times negative 16, right, is positive 16, and negative 1 minus 16 is negative 17. Okay, so if you're clever, you got it on the first try. So now we split up the middle term. I have to write it over again. Equals 0. So split up the negative 17x as negative 1x minus 16x. Factor by grouping. Take out the x. So it's x times 2x minus 1. And from the last two terms, we have to factor out a negative 8. You're left with 2x minus 1. Okay. This one's a long one. You factor out the 2x minus 1 times x minus 8. So I think that's the 2x squared, right, minus 17x plus 8. We factored that. Now, set them equal to 0. So we either get x equals 8 or x equals positive 1/2. So again, two answers. Okay. Let's go on to part G. Okay, we want to solve 3x squared equals 9x plus 30. And we saw one like this earlier. The problem is that the right side here is not equal to 0. So we'll have to subtract the 9x from both sides and the 30 from both sides. So now it equals 0. Okay, so a is 3, b is negative 9, c is negative 30. However, everything is divisible by 3, so I would factor out the 3 here. Okay, makes it much easier. And in fact, you can divide by 3, right? The 3 doesn't matter. The 3 is not an answer here, right? So at this stage, we just have to factor x squared minus 3x minus 10, and then we'll set it equal to 0 to solve it, right? And you could use the AC method, but what two numbers multiply to negative 10 and add to negative 3? So it's not negative 10 and 1. It's negative 5 and 2. Negative 5 plus 2 is negative 3, right? So, yep. At this stage, you just set them equal to 0. And you get x equals 5 or x equals negative 2. So again, two answers. All right, last one, part H. And although this is not a quadratic equation, right, because the exponent here, right, is a 3, not a 2, right, we did one like this in the video for 6.7. Right, and the way it works is it is in standard form because it equals 0, but notice that there's an x in both terms. So the GCF here is just x. So we'll factor out the x, leaving you with x squared minus 16. Right. But x squared minus 16 is, again, the difference of two perfect squares. Right? It's a squared minus b squared, where a is x, right, and b is 4. So a minus b is x minus 4, and a plus b is x plus 4. Right. Now we set all three factors equal to 0, so we get x equals 0, x minus 4 equals 0, and x plus 4 equals 0. So x equals 0, when you solve that, you get well, x equals 0, right? Not much to do there. And then for the second one, you have to add the 4 to both sides, so you get x equals positive 4. Oops. And for the last one, you have to subtract the 4 from both sides, giving you x equals negative 4. Okay, so this equation actually has 3 solutions, 0, 4, and negative 4. So all 3 of these are solutions here. Okay? Yeah, and that's as hard as it gets. I mean, in fact, you're probably not going to see too many of these on the test. Most of them will be quadratic equations where it's just x squared. And in those cases, you're going to get, at most, 2 solutions. This is a very rare case where you actually get 3 solutions. But usually you just get 1 or 2. All right, so now we come to the word problems, the applications. And these are all from section 6.8. So we just did these in the last video, but it's more practice. There's nothing wrong with that. So number 3, if the area of a square is 49 square centimeters, find the lengths of its sides. Okay, well, I would just draw a square. And we don't know the length of a side, so you can call that S if you like, for side. Right? And it's a square, so all 4 sides are equal. But we want the area of this square. The area, what's inside here, is just length times width, right? The length is S, and the width is also S, so the area is S times S, or better yet, S squared. And they tell us the area is 49. So we just have to solve the equation, S squared equals 49. Okay, and this is a quadratic equation. We just solved these, right? So I'm going to show you the way you're supposed to solve it here. You're supposed to get it in standard form, right? Subtract the 49 from both sides. And now factor the left side. This is a squared minus b squared, right? So s minus 7 times s plus 7 equals 0. Now, when you set these equal to 0, you get 2 answers. You get s is equal to positive 7, or s is equal to negative 7. And these are in centimeters, right? So I should put 7 centimeters or negative 7 centimeters. Now, what's the problem with that, right? It's the length of a side. Length is not a negative number. So I think we can cross out the negative answer here. So there's only one reasonable answer. The length of the side, right, is going to be 7 centimeters long. And that's it. And I think I brought this up in the previous video. Some of you might be tempted to do this. You might say, well, look, all I need to do is take the square root of both sides. And the square root of 49 is 7, so I get 7 centimeters. I get the same answer. What's wrong with that? Well, in this case, there's nothing wrong with that. However, I would claim that this is a very bad habit. If that's the way you do it, right now it's okay, right? You got the right answer. But in the future, this could get you in trouble, right? Because if the question was to say, just solve this equation, and you only write down x equals 7, then you're only getting half credit because there's 2 answers. There's x equals 7 or x equals negative 7. So you're missing the negative 7. Right? Now, I know in this problem, we crossed out the negative 7, but in this problem here, there's no reason to cross out the negative 7. It's a perfectly good solution. In fact, you can check. If I take negative 7 times negative 7, I get 49. Right? So it is a solution to this equation. Right? It's just that one that we discounted in the word problem because length is not a negative number. That's all. So if you insist on doing this, please don't make it a bad habit. Anytime you take the square root of both sides, always take the positive square root and the negative square root. Right? And then in this problem later, you can cross out the negative, but in general, you want to leave them both. You want to consider them both and then realize that, well, if length is not a negative number, we can cross that one out. Okay, so yeah, you're welcome to do it this way, but please get into the habit of adding the plus or minus anytime you take the square root. Okay, a rectangle has an area of 60 square inches. So let's draw a rectangle. Right, we know the area inside is 60 square inches. Oops, sorry. The length, so this is the length, this is the width. The length is 4 inches longer than the width. Right? So we know that the length, whatever the width is, just add 4 inches. Right? And remember, the area is length times width. And we know that's 60 square inches, right? So remember how this works? All I'm going to do is replace this L here with this L. And if I do that, I get W plus 4 times W equals 60. Right? And we've seen equations like this before. So now we just have to solve this equation, and that'll give us our answer. Okay, so multiply this out. W squared plus 4 times W, right? I'm just distributing the W here, equals 60. So this is a quadratic equation, but it's not in standard form. We have to subtract the 60 from both sides, right? So now we have W squared plus 4W minus 60. So to solve this, we have to factor it. What two numbers multiply to negative 60 and add to positive 4? Right, so you can write out the list, right? It's not going to be negative 1 and 60, or negative 2 and 30, or negative 3 and 20, or negative 4 and 15, negative 5 and 12. Nope. How about negative 6 and 10? Yeah, 10 minus 6 is 4, right? So W minus 6 times W plus 10. Right, now just solve. So W minus 6 equals 0 gives you W equals 6, and this is 6 inches. Or W plus 10 equals 0, giving us W equals negative 10 inches. And just like in the last problem, we're going to ignore the negative 10 because, well, it's a length. It doesn't make sense to measure a negative 10 inches, right? Okay, so if W is 6, that's the width, 6 inches, what's the length? Right. Well, L is just W plus 4, so 6 plus 4 is 10. So the length, oops, is 10 inches. And that answers the question, right? The question is to find the length and width, and we did that. Length is 10 inches, width is 6 inches. And as a check, 10 times 6 is 60. So, right, so to find the area, just multiply 10 times 6, and that gives you the 60 square inches we got, right? Great, moving on. Another rectangle, right? So this is a rectangular garden that has an enclosed area. So here's, I'll put it on the right here now, right? So here's the garden. Let's try that again. A little sloppy. Right, so we have an area of 144 square feet and a perimeter of 50 feet. Okay, so I don't think we saw one like this. So this is interesting. I think we can figure it out, right? We have the length, we'll call L. And we have the width, oops, we'll call W, right? But this is also the length up here, and this is also the width. So what do I mean by perimeter? Hopefully you remember perimeter is just the distance going around the rectangle. So if I add up starting here, going this distance, plus this distance, plus this distance, plus this distance, I get the perimeter. So in this case, it's L plus W plus L plus W, or 2 L's and 2 W's, right? 2 lengths and 2 widths. Okay. So that has to be 50 feet, right? Because that's given. That's the perimeter. But notice you can factor out a 2 here, although you don't have to, but it helps, and then divide by 2. So L plus W, the length plus the width, is 25 feet. Right? 50 divided by 2, of course, is 25. Right? Okay, so keep that in mind, right? That the length plus the width has to be 25 feet. Okay. Now, notice what we didn't use yet. We didn't use, we didn't use that the enclosed area is 144 square feet. So area, once again, is length times width, and that has to be 144. Okay, yeah, square feet. Okay. But notice that we know what L is. L plus W is 25. So if I subtract W from both sides, I get that L is 25 minus W. Right? But that means this L is also 25 minus W. So multiply that by another W, and that gives you 144. Right? So this is just L times W equals 144. And I simply substituted for L the equivalent expression for L, right? 25 minus W. Okay, so this is the equation we need to solve, right? Expand it out, multiply it out. We get 25W minus W squared equals 144. If you want it to equal 0, you subtract the 144 from both sides. So negative 144 plus 25W minus W squared equals 0. And this looks backwards, so I'll put the negative W squared in front, plus the 25W minus the 144, and that's still equal to 0. I think we can factor out a negative 1 here. We don't have to, but it might help. And just divide by the negative 1. Doesn't matter. So W squared minus 25W plus 144 equals 0. Now it's in standard form, and A is 1. Let me write that down, right? A is 1, B is negative 25, and C is 144. So what two numbers have a product of 144 and a sum of negative 25? Right. So clearly it's not going to be, 12 and 12, or in this case negative 12 times negative 12, because that adds to negative 24, which is close, but it's not negative 25, right? So how else can we multiply two numbers and get 144? Right, so they both have to be negative. We could do negative 1 and negative 144, but that's negative 145. We could do negative 2 and negative 72. That's negative 74. I think we can divide by 3. And that's 48, yeah. So negative 3 plus negative 48 is negative 51. We're looking for negative 25. If we divide by negative 4, we get negative 36. When you add those up, you get negative 40. Still no match. I don't think we're going to be able to divide by 5. But if we divide by negative 6, we get negative 24. Add those up, you get negative 30. So we're getting closer. Can we divide by negative 7? No, but negative 8. Sure. Negative 8 times negative 18. Just making sure. Yep. And when you subtract those, you get negative 26. We're looking for negative 25, so even that doesn't work. So what do? We divide by negative 9, and we get negative 16. So negative 9 plus negative 16 is indeed negative 25. So those are the two numbers, right? So we can factor this directly as w minus 9 times w minus 16. Phew, that was a long one. Again, maybe some of you thought this was obvious. Great. I didn't. I had to go through the whole list here. Right? And of course, I started with the negative 12 and 12, but that didn't work either. All right, well, we're almost done, right? If w minus 9 equals 0, that tells me that w is 9. Or if w minus 16 equals 0, that tells me that w is positive 16. Okay, now this is interesting. These are in feet, I think, right? But neither one of these is negative. So I don't think we can cross any of these out. Right, so this is interesting. So if, let's say w is 9, what's L? Remember, L was 25 minus w. So 25 minus 9 is 16. So if the width is 9 feet, then the length is 16 feet. So what if the width is 16 feet? Well, then the length is 9 feet, right? So, oops, sorry, that's supposed to be a length is 9 feet. Can't draw 9 feet, right? So it's the same rectangle, right? If the length is 16 feet, so this is 16 feet, this is 9 feet. Over here, the rectangle just gets flipped like this. So here, the length is only 9 feet, and the width is 16 feet. Okay, so yeah, both are correct, right? There's no reason to say that the length has to be longer, the width has to be longer here. So the question is, find the dimensions, the length and width of the garden. So the answer is the garden is 16 feet by 9 feet. Right? So 16 feet by 9 feet. Or you could say 9 feet by 16 feet, right? Either way. Those are the dimensions. Okay? Yeah. So that's what happens when you have a perimeter problem. Again, you're probably not going to see those because it didn't come up in the homework. So a little bit harder than it had to be here at the end. But still a reasonable question, I think. All right, so let's move on to number 6. Okay, the product of two consecutive odd numbers is 143. Find these two odd numbers. Okay, so these are just those number puzzles, right? So two consecutive odd numbers, right? So let x be the first one, right? And then the next one, because it's an odd number, you have to add 2, right? Same if it were even, right? So, right, 3 and 5 are odd, and 3 plus 2 is 5, right? These are consecutive odd numbers. Right. However, when you multiply them, the product is not 143, it's only 15, so that was a bad guess. But that's just to illustrate why you need x and x plus 2 rather than x and x plus 1. Right? So we talked about this in the previous video. Because we're talking about odd numbers, to get to the next odd number, you add 2. So let x and x plus 2 be these two odd numbers. All right. What do we know about these two numbers? Well, we know that the product, right, the product is 143. So all I have to do is multiply the two numbers, the x and the x plus 2, and that has to be 143. So there's our equation. We just have to solve it. So let's multiply it out. X times x is x squared, plus x times 2 is 2x, and that has to equal 143. So we can put this in standard form by subtracting 143 from both sides to get 0 on the right. And now we can factor. Right? What two numbers multiply to negative 143? So here's the product is negative 143, and the sum has to be positive 2. So let's start with the obvious negative 1 times 143. Negative 1 plus 143 is 142, which is not 2. So we're not even close, right? So now we just keep dividing. We know we can't divide by 2, or 3, or 4, or 5, or 6, or 7, or 8, or even 9. I know I'm skipping these, right? 10 doesn't work either. 143 divided by 11 is 13. So we have negative 11 and 13. So yeah, everything in here I'm skipping, right? The negative 2, negative 3, negative 4. None of these divide evenly. So I don't even bother writing them down. That's fine. But negative 11 and 13 work, right? And negative 11 plus 13 is the 2 we needed for the sum. So yep, it's x minus 11 and x plus 13. So if x minus 11, is 0, then x is 11. That's a perfectly good odd number. And if x plus 13 equals 0, x equals negative 13. Okay. Now, you have to be careful because these are not the answers. Right? 11 and negative 13 are not consecutive numbers, or they're not consecutive odd numbers. Right? Draw a number line. Right? So negative 13 is way over here. The next number is negative 11. Right? Then negative 9, negative 7, negative 5, negative 3, negative 1, positive 1, positive 3, positive 5, positive 7, positive 9, positive 11, and then 13. So 11 and 13 are consecutive odd numbers. Right? And then negative 13 and negative 11 are also consecutive odd numbers. It doesn't say positive, right? The product of two consecutive odd numbers. Yep, they don't have to be positive. Right, so there's two possible answers, right? 11 and 13 or negative 11 and negative 13. Oh, I said it backwards. Negative 13 and negative 11. Okay, so that's number 6. Right, number 7, one leg of a right triangle is 3 feet longer than the other leg. Okay, so let's draw a right triangle here. So one leg, I guess I'll call this A, I'll call this B and C. Right. So you remember Pythagorean Theorem, A squared plus B squared equals C squared. Keep that in mind. Now one leg, let's say B, is 3 feet longer than the other leg, A. So that means B is just A plus 3. Right. And the hypotenuse is 15 feet, so C is 15. So that comes for free. But we're looking for A and B, right? We're looking for these two sides here, right? Okay, so plug these numbers into the Pythagorean theorem. We know what C is, right? C is 15. And 15 squared, 15 times 15, is 225, right? Now, we don't know what A is, and we don't know what B is, except that it's 3 feet longer than A. So B is really just A plus 3. Don't forget to square it, right? So this gives us our equation. Right? Now we just have to solve this equation. So I'll put that way up here. Right, so how do we solve this equation? Right, it is a quadratic equation, and it's not in standard form, so we'll have to subtract the 225 from both sides. If you want to do it now, that's fine. I was going to do it later. Okay, but we also have to expand all this out. So the a squared is fine. A plus 3 times a plus 3 is a squared plus 6a plus 9. And I hope you're not asking the question, wait, where did the 6a come from? Right? So if you're asking that, again, you have a very bad habit here. Here's your bad habit. You're thinking of a plus 3 squared as a squared plus 3 squared, which it is absolutely not. And if you make that mistake, you're going to get it wrong every time. Okay, so let's remember what a plus 3 squared means. It means a plus 3 times a plus 3. Right? So you have to FOIL. A times a is a squared. The outside is plus 3a. The inside is plus 3a. And then the last 3 times 3 is 9. So where did the 6a come from? Well, the outside plus the inside, right? 3a plus 3a is 6a. So, right, and probably the last time I'll do this, because I'm assuming that none of you are making this mistake anymore. All right, so anyways, that's where the 6a comes from. So we're good. All right, now what? Well, a squared plus a squared, right, is 1a squared plus 1a squared is 2a squared. And 9 minus 225 is going to be, oh, it's going to be negative. Sorry. We'll erase the positive here. It's going to be negative, what, 216, right? I think. Yep. So now we have our equation in standard form. Right? A is 2, not this A, but right? A is 2, B is 6, and C is negative 216. And these are some big numbers, but to factor this, I would first factor out the 2 as the GCF. And you can divide by 2. Let's get that out of the way. So a squared plus 3a minus 108 equals 0. Right. Now all we have to do is look for two numbers whose product is negative 108 and whose sum is positive 3. Yeah, so I'll let you think about this for a second, or write out the list if you have to. Okay, it should be negative 9 and positive 12, right? So that multiplies to negative 108, and negative 9 plus 12 is indeed positive 3. So, yep, a minus 9, a plus 12. So a is either 9 or negative 12. So let's see, this is a triangle. Can the length be negative? I don't think that makes a lot of sense, right? So we can definitely cross off the negative 12 here, leaving us with only one valid answer, and that's 9. Oop, don't forget feet. Okay. Oh, and we're looking for two things here, right? We're looking for both legs. So we know what A is. What's B? Right? So remember, A is 9, and B is just A plus 3. So 9 plus 3 is 12. So A is 9 and B is 12. So to fully answer the question, right, what are the lengths of the two legs? The lengths of the two legs are 9 feet and 12 feet. Neither one should be negative. All right, that's number 7. Okay, number 8. The sum of the squares of two consecutive positive integers is 85. Find the two integers. All right. Well, the sum, so right, we're looking for two numbers, two integers, and notice they are consecutive positive integers. So let's let x and x plus 1 be the two consecutive, right, one after the other, consecutive, and they should be positive numbers, right? So if we get a negative number, we can cross it out. Integers just means that they're whole numbers. So if we get a fraction, right, like 2/3 or 1/2, we can cross that out as well. Okay, so we got to find x, and once we know x, we just add 1 to get the next whole number, right? Right. So these are the numbers we're looking for. What do we know about these two numbers? Right. Well, we know the sum is 85. But wait a minute, not the sum of the two numbers, right? The sum of the squares of the two numbers. You have to square these. That is what is equal to 85. The sum of the squares, right, of the two consecutive positive numbers, right? So that's the equation. Go ahead and solve it. And you should get this equation here, right? X squared plus x squared plus 2x plus 1. I'm not going to explain the 2x again. You should know that's just x plus x, right? When you have to FOIL this out. And x squared plus x squared is 2x squared, right? Plus 2x plus 1 equals 85. And I think at this point we should put it in standard form. So subtract the 85 from both sides. And that gives us 2x squared plus 2x minus 84 equals 0. And now it's in standard form, but the GCF is 2. So why don't we factor out the 2? Right? And now, again, you can divide by 2. That doesn't matter. Obviously, 2 is not the answer. Well, yeah, it's not obvious, right? But 2 is not the answer because it's the coefficient. It's not x equals 2, right? You're dividing by 2. 2 divided by 2 is 1. So x squared plus x minus 42 equals, well, 0 divided by 2 is still 0. So how do we solve this? Usual way, factor it. What two numbers multiply to negative 42, and add to positive 1. There's an invisible 1 there. And surely you got negative 6 and positive 7, right? Negative 6 times 7 is negative 42, and negative 6 plus 7 is 1. So if x minus 6 equals 0, x is 6. And if x plus 7 equals 0, x is negative 7. But remember, in the problem, we're looking for two positive numbers. So I think we can safely cross out negative 7 just because it's not a positive number. Right? And that leaves us with x equals 6. Okay. But remember, we're looking for two integers, two numbers. Right? If x equals 6, what's the other number? The other number is, well, the next consecutive number, x plus 1. Right? So x plus 1 is 6 plus 1. Obviously, the next number is 7. Okay, so the two numbers are 6 and 7. And that's it, right? Two consecutive numbers are both positive, right? And you can check, right? If I take the sum of the squares, 6 squared plus 7 squared, I get 36 plus 49, which is indeed 85. And that's, right, that was the 85 here. That's the sum of the squares of the two numbers. So we know this is correct. 6 and 7 are the two numbers. All right. Now moving on to number 9, we have the sum of two numbers is 11. Well, okay, so we're looking for the two numbers, right? Let x and y be the two numbers. But the sum is 11. So if you know one, you know the other, right? If x is 5, y is 6, right? It's just 11 minus x. So we don't need the y here, right? We can cross out the y and just say the two numbers are x and 11 minus x. Right? So those are the two numbers. And what do we know about these two numbers? We know that the sum of the squares, okay, same thing that we had earlier, is 65. So if we square them and then add them up, we should get 65. Right, so now we just have to solve this equation, and that'll give us x. So multiply this out, you get x squared plus 11 squared minus 2 times 11 times x plus x squared equals 65. All right, so 11 times 11 is 121 minus 22x plus x squared equals 65. Everyone okay so far? So we have x squared plus x squared, that's 2x squared. And then I'll put the negative 22x after that. And then the plus 121 equals 65. So this is starting to look like a quadratic equation. But to get 0 on the right, we'll take away the 65 from both sides. And that leaves us with 2x squared minus 22x plus, well, 121 minus 65. Looks like 58. I'm sorry, 56. Yep, 56 equals 0, right? Right, so now it's in standard form. And again, factor out the 2 as the GCF. It makes it a lot easier to factor out the 2. Yeah, 56 divided by 2 is 28. So again, divide by the 2. So the usual question at this point, what two numbers multiply to 28 and add to negative 11? Well, 7 times 4 is 28. 7 plus 4 is 11. So to get negative 11, we'll do negative 7 and negative 4. So that means x is either 7 or x is 4. Right? They're already both positive, so we don't have to worry about that. So then what's the other number? Well, remember, the other number is 11 minus x. Well, 11 minus 7 is 4. Or 11 minus 4 is 7. So you get the idea, right? They're, in this case, they're both correct, right? So the two numbers are 7 and 4. So the two numbers are 4 and 7. 7 and 4 doesn't matter the order, right? Because remember, the first condition is that the sum of the two numbers is 11. 4 plus 7 is indeed 11. Right? So that works. And then when you plug them into this equation, and you should get 65. So I hope that helps. That's number 9. Okay, finally, number 10. And this, I think, is the last one. So we have a rock is dropped off of a 400-foot building. Its height, h of t, above the ground as a function of time, t in seconds, is h of t equals negative 16t squared plus 400, and that's in feet. Find the amount of time it takes to reach the ground. Okay, so we've done things like this, right, in the previous video. Here's the building. This is a tall one, right? This is 400 feet tall. Right? And we're going to drop a rock, let's say it's red, off the top of the building. How long does it take before it, crashes into the ground? That's the question. Okay, so they give us the equation here. And, this is kind of a typo here. This h of t, a lot of students look at this and say, so this is h times t, because, right, parentheses usually means multiply, right? Well, this is a vestige of really years ago when we used to do functions first. So in this case, this is h of t. This is a function of t. So let's forget the of t here and just call it h. Okay, so it should be h equals negative 16t squared plus 400. We didn't talk about functions yet. So this is something we'll see, in a few more weeks. This is called a function. But since we didn't do that yet, let's not bother. Okay, so sorry if that was a little confusing. If you're trying to multiply h times t, that's not what that meant. So just like in the previous section, we're just going to write it as h for height, right? And t for time. Okay, and this is the equation. Right? Find the amount of time it takes for the rock to reach the ground. Well, remember, if this is 400 feet above the, 400 feet above the ground is 0 feet. So again, the question is to set h equal to 0, because that's where the ground is. It's level 0, right? So we just have to solve this equation. Negative 16t squared plus 400 equals 0. Again, why 0? Because that's where the ground is. We're measuring feet above the ground. So 400 feet is the top of the building. That means it's 400 feet over solid ground, right? All right, so now we just solve the equation. And this one by now should be pretty routine. After all, negative 16 is the GCF. You factor out the negative 16, and you're going to get t squared minus, I want to say 25, right? 400 divided by 16 is indeed 25. All right, just making sure. So we can divide by the negative 16, right? That's not the answer. And now we just have to factor t squared minus 25, which at this point should be really easy. It's just a squared minus b squared. So a minus b times a plus b. And so that gives us, well, I'll write out the equations again. Two possible answers. T is either equal to positive 5 or t is equal to negative 5. Well, negative time, I guess it makes sense. It just means 5 seconds ago, right? This is in seconds. But when we dropped the rock, that was at time t equals 0. So 5 seconds ago, we don't care where the rock was. It's not on the ground. So it's 5 seconds after we drop it, right? So we'll use the positive 5 seconds. Right? So I think that's the answer. It takes 5 seconds for a rock. If you drop it off a building, make sure you don't hit anybody. It'll take 5 seconds before it reaches the ground. So it's in the air for 5 seconds. Makes sense? Right. So yeah, little physics question here. But again, the equation itself was given to you in the problem. You just have to erase the parentheses t here. All right, so I hope that helps. Yep, so these are the applications that you get from section 6.8. So as long as you've done the homework and you've looked at these practice problems, you should be okay. They're not going to get any more difficult than this. And that's it for the practice test. So hopefully this, good luck on the test. It's really not going to be that bad. Just keep doing the homework, keep doing the quizzes, and, hopefully you actually did some of these practice problems before you watched me do them. Again, the idea is you do them first, and then if you get stuck, you can always watch the video. So, all right, this video's gone on long enough, and all I can say is good luck for test 2.